In this video, we're going to be talking about the normal distribution. The normal distribution is a continuous probability distribution. If you remember, all of the probability distributions we saw in Chapter 5 were discrete. Now we're going to look at a continuous one. The graph of a normal distribution is a normal curve, and the normal distribution is called the normal distribution because it shows up very often in nature. Many real-life data sets are approximately normally distributed. Here we have a picture of 3 different normal distributions. They all have the same basic shape, which is a bell shape like this, and there are a couple of other things that they have in common. Some are taller and more dense around the middle, some are shorter and more spread out, but they all have the same basic shape and a few other things in common. Here's an example of some normally distributed data based on birth weights of newborns. We have a histogram based on data that was taken, and it has almost what looks like a normal curve over here. Here's another example, average heights of American women. When we graph the data, we see that the curve it takes on looks a lot like a normal curve. Same thing over here. If we look at this example, distribution of shoe sizes in UK men. Again, we see the same type of curve happening over here. And this happens a lot in many different populations in real life. And it happens so often, that's why they decided to call the normal distribution the normal distribution. Another example of the normal distribution is the COVID curves. Now we'll talk about some basic facts about the normal curve and the normal distribution. The normal curve is bell-shaped. Sometimes it'll look like this, sometimes it's more spread out, or it's shaped a little bit differently, but it usually has a shape that's very close to this one. The second fact, the total area underneath the curve is equal to 1. Another way you can think of that is that 100% of the data is represented underneath the curve. The third fact we have is that it's symmetrical about the mean. So what that means is if we draw a line down the middle of this curve, the mean would fall right over here, and these two sides of the normal curve are completely equal. When we get to some problems later, we're going to combine the second fact and the third fact to solve some problems. So if the total area under the curve is 1, and we know that this curve is completely symmetrical, that means each half of this curve is going to have an area of 0.5. And if we add the 0.5 plus 0.5, that equals 1, which is the total area under the curve. So this is something we will be using later. Now some more information about the normal curve and how data falls within it. You have approximately 68% of the data within 1 standard deviation of the mean. So remember, we have the mean in the exact center of our normal curve. And then over here you have plus 1 standard deviation. So if we were working with z-scores, this would be 1. This is 2 standard deviations above the mean. This is 3 standard deviations above. This is going to be 1 standard deviation below the mean, 2 standard deviations below, 3 standard deviations below. So between -1 standard deviation and +1 standard deviation away, we have 68% of the data. Then within 2 standard deviations of the mean, we have 95% of the data. And then within 3 standard deviations of the mean, we have 99.7% of the data. Now we'll talk about the standard normal curve. So a lot of the real-life examples we saw, the normal curves were all shaped a little bit differently, even though they all had the same basic bell-shaped curve. The standard normal curve is a special normal curve where the mean is equal to 0 and the standard deviation is equal to 1. This is what the standard normal curve looks like. When we get to solving problems, if you are not relying on the calculator, we're going to have to go through a process where you may be given information about a different normal distribution. There's a simple way of converting what you have into a standard normal distribution, and then you're going to be able to solve problems using tables. If you're using the calculator is basically going to do what you would be doing with the tables, but the calculator does it through its own programming. Now we have something called the z-table, and this is what we're going to get into in the next section. So basically what the z-table does is it'll tell you the amount of area between 0, or the mean, since this is a standard normal curve, and some positive z-score. So if you want to figure out what the percent of area is between 0 and a positive z-score, you're going to be able to look that up on this table. And this table has already been uploaded to Google Classroom, so you have access to this table. I recommend printing it out so you can use it with you on exams and on quizzes. In the next video, we will look at some examples where we solve problems using the z-table.